mainly between 22 and 36 years old. It includes 549 males and 657 females, while only 1,003 subjects have complete data. The age at intake histogram and age at intake split by gender graph were shown here. It is also important to note that the dataset has already been processed by the Plankton Coordination Facility rather than the original fMRI image dataset. The processing process of the dataset is quite complex, like the flowchart shows here. Finally, each subject will obtain 4,950 features according to the correlation coefficient of their region of interest, which is the dataset I actually use. The goal of this project is to use a variety of algorithms to construct prediction models of individual spatial orientation ability based on the functional connectivity features extracted from the resting state fMRI data and verify the feasibility and accuracy of the prediction, in addition to compare, analyze, and summarize the influence of different algorithms on the model effects. For the connection and creativity part in this project, functional connections represented by temporal correlation between regions of interest are used as machine learning features, and spatial orientation abilities represented by reliable short pin line orientation test scores are used as prediction labels. This label is rarely mentioned in other relevant studies and is a relatively innovative target. In addition, this project will compare the differences in the performance of different algorithms, which is also rare in other studies. The figure on the right side is a schematic of the pin test. In this dataset, there were 1,206 subjects, but only 1,003 have complete data. Therefore, during pre-processing, the data containing null values should be removed first. I simply use a loop to find null values and delete them. After the null values are removed, they are normalized using standard scalar from sklearn. Since there are only 1,003 valid samples in this dataset, but each sample has 4,950 features, it's obvious that the sample features must be selected. I used a univariable feature selection method and conduct experiments with 3 different variables, which are the Pearson coefficient, F regression, and mutual information regression. The results obtained are shown in the table. It can be seen that when F regression is used, the minimum mean square error is obtained and the maximum R square is obtained, which means the best effect. Therefore, F regression will be used for univariate feature selection.
Sorry to interrupt you, Jeroen. You're out of time. Can you please wrap up quickly?
Okay, this is the end, actually.
Yeah, cool.
So,
okay, so just a quick question. Did you have any samples of the data? Like an example, what is in the data? Is it a tabular data?
No, it's actually just like a chart. It's a MAT flow. It's a MATLAB flow. It has been pre-processed by the CCF, so it has been already transmitted from image to the numbers. It's
okay. So some features are extracted from the images.
Yes.
Did you? That was the first slide. The features that you showed. Can you go back again?
Okay. Oh, you mean this? Or...
So is this age at intake histogram? Are these the features, or the features are different from this?
No, they are not the features. This is the age of the subjects of this data set.
So do you have a list of the features?
The feature is the temporal relation coefficient.
Oh, temporal okay.
Yeah, between different regions of interest, and because it has 4,950, it's hard to realize them.
Yeah, I understand. I was just curious about seeing a sample. That's great. Thank you very much.
Okay.
So we can move to the next speaker. Hairu, are you here?
I will share my screen.
Yeah.
And you see the screen?
Yeah, we can see. Go ahead, please.
Okay, hello everyone, this is Hairo, and my project topic is common sentence analysis. And I will introduce my data and programs into 3 parts. Firstly, I will introduce my data component is made by 6 labels and ID, which can be used to position data. Time and reverse, these two are set to avoid the duplicate comments. Comments, this is the main features used in common situation analysis. Attitude, this is the target should be get from the comments, and it has 3 options, negative, positive, and none. None means this data has no attitude. And lastly is the label to decide this data is used in train or text. And the comment is the CSA is the function to analyze the comment to get the attitude and trained by the train city and tested by the data set. And for my data set, there are totally 600 data with 230 negative comments, 247 positive comments, and 140 non-comments. And it can be randomly, and I have randomly divided into 300 tests and 300 trains. And to put it all in test data set, there are 107 negative comments, 69 non-comments, and 124 positive comments. And in data set, there are 106 negative comments, 71 non-comments, and 123 positive comments. Then I will introduce how did I get the dataset and deal with it. This is the environment I configured. The dataset is from the film review website means Rotten Tomatoes, and the film is Jojo Rabbit. To get the dataset, firstly I get the whole page information by send request. Then I select the features by finding the feature I need copy selectors and using the select function to get the test. After getting the oriented data sets, I set the limitation of comments as written in English and attitude should have 4 marks. And then I found the point is as not the attitude but as the point. It has the 2 fractions and ABC, and I changed it into the attitude, positive and negative. And then I render the trim and the desktop. Finally, I save it on local, download it. And this is my project goal. Step 1, analyze, get the function by the algorithm. Step 2, train it. Step 3, consider this factors which can improve it. Okay, that's all.
Okay, that's great timing. I was going to say your time is up. So that's great. You created your own data set?
Yeah, I own my own data set.
Okay, can you
from the website?
Yeah, can you say what was the labels again? The attitude?
Oh, label.
It's positive and negative?
The 6 labels, yeah.
And how did you get the attitude from positive? Is that again available somewhere?
I get the attitude in 3 kinds. The first one is to make the long to the non to the long. Can see this one is no attitude. I change it to if they can get none. The second one is some points, and I change this point to find and to calculate the points. If the below the 0.5 connect over the point. The second one is ABC, A plus B, and I can see the A plus A the point, B the negative. This is the 3 methods I deal with my data set.
That's great, thank you. And we'll have to move to the next speaker, Shri, if you're ready.
Hi, I'm here.
Yeah, go ahead and share your screen when you're ready.
Share my screen. Is it visible?
Yes, it is.
Okay. So, Hi, my name is Shrey. My project is focused on building a machine learning application which can predict the severity of COVID-19 cases based on a patient's symptom. So I was actually advised by Dr. Kivu that finding the data set for this problem might be a bit tricky. And I can confirm that Dr. Kivu was right indeed. Like I found many data sets, like COVID related, but not a lot of them suited my case. But finally, I found a small data set in which COVID information is based on the guidelines of given by WHO and Ministry of Health and Family Welfare India, which kind of suited my project needs. So this is the original data set. As you can see in it, the most important features from this data set for my project were age, gender, symptoms. And the symptoms, like the first column is that an individual is supposed to have if they have COVID. And then again, the other column is the actual symptoms that were experienced by individuals. And finally, severity. But this data set was not as I expected, like in terms of the size and features provided in it. So I had to expand this data set. So now to expand this data set, I thought of dividing all the symptoms as individual features and creating a data set out of all the possible combinations I could get from the original data set. So I selected all the unique values and dropped all the null values from the original data set, and then produced the combinations using ITER tools, since like it's fast and more energy efficient. So the two main columns, like for symptoms and experiencing symptoms, were broken down to individual features and given the value of 1 if the symptom was present for the particular tuple in the produced combination. So the original 2 columns were finally like dropped from it. So the expanded data set has about 300,000 columns rows, and 27 columns, which were all unique values generated from the original data set. So these are the 27 generated features or columns in my final expanded data set. And I was able to like further analyze features in the expanded data set through individual histograms to understand how a particular feature was spread. And it's just like 6 of them, but I've done like for all of the features. Also, I was also able to analyze like the features by getting their mean and standard deviation like throughout the data. So finally, I was able. So I have like how can I connect this to my project goals? Is like I can use the indicator values generated to further analyze the data.
Sorry, Shrey, to interrupt you. Your time is up. Can you please wrap up?
Yeah, all right. So just grouping them on base of severity and generate symptom scores, which would be my goal. And then again, use different algorithms to train the classifier. Thank you. That's it.
Thank you. So my question is, you said that you combined the data for the ones that didn't have all the features. Is that correct?
Yes.
And then if you are combining them randomly, what was the task again? What are you trying to predict from those features?
So I'm trying to predict the severity of COVID cases. Like if you have COVID and if you tell me the symptoms, how many symptoms do you have? I can tell how severe your infection is. So depending on like your age and symptoms which you show.
But if you combine these data randomly, then the labels would change, wouldn't it? Like the severity of the samples that you're generating, because you're mixing the features, the severity wouldn't be the same as before, would it?
I mean, I'll have to.
I mean, you're generating more data by randomly combining different features, right? Is that, if that's correct, then the new data that you're generating, it's not guaranteed that it would have the same labels as before. If you had the labels for the severity, or you didn't have the labels at all.
Yep. I mean, there was a severity label in the original data set. And so according to that, I've connected the other symptoms.
Yeah.
originally the severity was present in the original data set, but the symptoms were combined in one column, so that's why I had to expand them.
Oh, okay. Cool. Thanks for that. We need to move to the next presenter. Varun, are you here already?
Yeah, hi.
Yes. Go ahead and share your screen.
Yeah. Okay. So I hope the screen is visible.
Yes, it is. Your 3 minutes is started.
Okay. So the project goal for which I will be working on is mainly related to HR application. So, and the goal or the aim is to predict whether an employee can be promoted or not. So since it is related to human resource domain, there was a need to have an HR data set for this project. And basically, as we are classifying or predicting whether an employee can be promoted or not, so it would be a classification task. Like 0 would be the employee cannot be promoted, and 1 would be yes, the employee can be promoted. So talking about the dataset information, the data referred for this study is available on Kaggle. It is called as IBM HR dataset. So it has a single CSV file, and the dataset shape is, it has around 1470 data points and 35 features. So drilling down further, out of 35 features, 26 are integer data types and 9 are object or string data types in the dataset. So, and this represents the overview or basic information on the dataset, that what are the feature names and if there are whether any null values and what are the data types. So if we can see over here that the dataset has no missing values or no null values. So about data quality in the original dataset, so there is no target variable that would help to achieve the target of this project. So the idea is to analyze the data and create the target variable and assign the labels. Like I said, 0 would stand for the employee cannot be promoted, and 1 would be the employee can be promoted. And here is the sample, like I had just started with the data analysis and assigning labels. And this is how I would like create the target variables. And then, like I said, the data quality, there are, for out of 35 features, there are certain prominent features that would help predict the employee promotion. Like there is a feature called performance rating, attrition, the job involvement, the number of companies the employee has worked previously, the number of time he has undertaken training, age. So there are a number of features that could help get the target of this project, achieve the target of this project. So for data preparation, the first part is data cleaning. So there were certain columns which had constant values, like employee count feature had only constant value 1, and there was over 18. So these columns didn't represent much information. So the idea is to drop the columns with constant values. And the technique used is using the function of pandas drop, and using that the columns were dropped. And like seen in the previous slides, since there are no missing values, there is no need to handle in data cleaning. And also then it was checked if there are any duplicate rows. So there are no duplicate rows as well. So that part was not handled in data cleaning part. Then for feature engineering, like I said, there are 9 categorical columns. So there is a need to encode those features. And the encoding is done like using pandas.getDummies. And after that, the modified data set was coming around 1470, and there were 54 features, increasing of around 1918 features. So about data transform or the need for scale.
Your time is okay. If you can please wrap up.
Yeah, sure. I'll just complete it first. So about data scaling, like since there is an involvement of classification task and building of classification models, there would be a need for scaling of data depending on the model that would be utilized, like KNN or SVM. So the project would involve scaling of data as well. And then this is the visualization that was carried out on features. Like first, the visualization was done to check the correlation between different features, and it can be seen that there is less correlation, and hence most of the features could be considered for the study. This is like involving categorical variables as well. And this and then this visualization was for some of the prominent features, like attrition, the count out of 1470, there are 1, 2, 3, 3 which are like probably wouldn't leave the organization, and around 237 which are probably are highly likely to leave the organization. And then these are the box plots to understand the distribution of the data for the prominent features again, like the age, job involvement, and then there is a number of communities worked and training times.
That's great. Thank you. We'll need to move to the next speaker. Sinha, are you ready?
Yeah.
So you can start sharing the screen.
Okay.
Are you still there? Hello? Okay, probably Sinha has some internet problem going on. Do we have Jonathan here and ready if you want to swap?
Yep, I'm ready.
Oh, that's great. You can start presenting and then we'll have Sinha after you.
Sure, no problem.
Thank you.
Give me 1 minute to share my screen. So let me know if you can see it.
Yes, it's all good. Go ahead.
Okay, cool. Hello everyone, my name is Jonathan and I'm here to present to you the data and project goals for my project. My project goal is to predict if a coin is in risk of being rug pulled. A rug pull is a malicious maneuver where crypto developers abandon a project and run away with investors' funds. To be able to predict if a coin will be rug pulled, I'm currently using 18 tokens of the initial dataset. The dataset is still in progress, so the data is troublesome to obtain. I'm using Etherscan as a data source. There you can obtain the information shown in the screen, mainly all the transactions for a particular coin and its details. I began by studying the data available and added a couple of new variables to my dataset. First was to identify if the transaction was a part of a rug pulled coin transaction. Another new feature was this percentage supply. Since all the coins have different supply, it makes it harder to compare them with just using the quantity. After adding the percentage, I removed the outliers to avoid inputting noise data to the model. The image shown represents the data before and after the removal of the outliers. You can see how the sample is less sparse. Another key part of the data cleaning is to fill empty data, which in my case was amount, type of token, and price when the transaction was transferred. In these cases, the data declared in the transfer were used. Finally, the price is estimated as a previous known price, since a transfer usually should usually not affect the price of the token. You can see an example where the green points are the new prices added to the data. I also removed a few features that were not necessary for the analysis, particularly transaction value and swap rate. The contract address was changed to the coin ticker, which is easier to understand, and the transaction hash was also removed. There are two types of data transformation. The first was to a few string-based features. These were in transforming using one-hot encoding technique. The other transformation was to the datetime, which was transformed using a delta between the transaction of each coin. For the dimension reduction, the removal of correlated columns that bear no variance was applied. In the heat map, it is easy to check that the block number, Unix timestamp, and datetime are closely related, so they were removed. After the preparation, the data consists of roughly 155,000 transactions. The number of transactions per coin ranges from 25,000 to less than 1,000. As you can see in the chart on the left, most of the transactions are fairly low in terms of percentage. Finally, to discuss a little about the behavior of the coin, it is clear, especially for rug projects, that there are times where the transactions tend to spike in terms of volume, while normal projects tend to have a less of these spikes and behave within the range of 0.01% per transaction. This means that the coin distribution is less centralized in a few accounts. That concludes the presentation for today. Thank you very much for your time.
Great, just a quick question. Did you say you generated the labels yourself?
No, the labels were from Etherscan, which is a site that has all of these labels available.
Okay, so you generated data from another source and then you pulled the labels from another. Is that the case?
No. So what I did in some cases, what I did was try to transform the data that they have. The other thing that in some cases they didn't have, for instance, the price of the coin. If I am doing a transfer, for instance, from my account to another one, they didn't have the price for that, so I needed to tweak a little with the data that I have. But all of the data is from just one source.
Okay, and that's where you basically handle the missing values. That's your tracking.
Exactly. So I use the values that I have to fill the void between them.
Cool, that's great, thank you. Do we have Xinhao again back? Xinhao are not here. Let me check. Don't seem to have Xinhao, so maybe we can move to the next speaker. Julian, are you ready?
Yep.
You can start then, please.
All right. Can you see my screen?
Yep, all good.
Okay, cool. So the project I'm working on is artist classification by spectrogram learning, and that involves identifying artists through their vocals. So I'll take you through the data that was needed for this project. So the goal is to classify artists by vocal characteristics, and to do that we need recordings of artist vocals. And we're looking for a data set that has both a large number of songs, diversity of time distribution, a diversity of vocalists, and a diversity of genre. So to do that, what I did was I went through my own local files of music to generate a data set comprised of 23 artists, divided into 261 albums, 3,097 songs, and about 200 hours of music. In relation to the time distribution of these songs, we have a healthy distribution, which is relatively modern, but also has some old samples to well distribute the date. In terms of vocalist distributions, as I said, we have 23 artists, which are relatively well distributed, but we might have to do some balancing for example, David Bowie or Queen. And in terms of genre diversity, we have a nice quarter split between the big genres of music, which are rock, rap, R&B, and pop. If we look at the pre-processing and cleaning pipeline that we took into account for these samples, the first part was data cleaning, which I did pretty much manually, which included removing songs that were less than 30 seconds, removing songs with multiple vocalists in it to avoid misclassifying these songs, and removing songs that had only instrumental parts. And the first part was done algorithmically, but the second and the third were done manually. And that leads us to a clean waveform data set. If we look at the steps the waveform goes through to lead to our full data set, we start with the waveform audio, which is just a whole song. So this is Ariana Grande's Positions, I believe. And we put it through a first backend algorithm, which was pre-trained, which is the Splitter algorithm from Deezer, which serves to isolate the vocal, which can be seen in dark blue compared to the whole song in light blue. So we have the isolated vocal, which then goes through splitting. So in green, you can see parts that are not silenced and red parts that are silenced. Once we've isolated those parts, we end up with an amount of n segments of the song, which are then put through some audio pre-processing, which includes time shift, amplitude modulation, pink noise, Gaussian noise, click track, and we have some natural augmentations, which is nice, which include remixes and live performances. And so we end up with which then are put through a spectrogram backend to generate a spectrogram, and put through some image augmentations, which include coarse dropout, cutouts, random brightnesses, and normalization, to end up with our final training set.
Sorry to interrupt you, Julian.
Sure, yeah.
It's thumbs up, can you? Okay.
So thanks for listening.
That's great timing and very good pre-processing. So is this a public data set, and is there any previous methods available on that?
So there are some previous methods, but they weren't used on pure vocals. They were used on the whole songs to identify genre and not really the vocalists. So it's kind of a new technical aspect. And regarding the data set, this is not a public available data set. It was generated from my own music library, taking into account Spotify's top 100 artists of all time.
That's very interesting. Thank you. Okay. Next speaker,
Thanks a lot.
Jiacheng. Cheers. Are you ready? Jiacheng? Yeah.
Can you hear me?
Yes, I can. Go ahead when you're ready.
Okay. Hello everyone, I'm Jiacheng Zhao. Today I will introduce the research on fact detection problem based on machine learning and data and project goals. The first, I will introduce the project goals. The project goals have three parts. The first part is use natural language processing to study fact detection problems. And the second is collect high quality relevant evidence documents. And the third is construction of deep learning model based on relevant evidence analysis. So in the final of the project, the prediction systems can give you systems which can help people. And when people read topics from the internet and they research the topic on the Googles, and then they input the topic and the relevant evidence in the systems, and the systems can give the people's outcomes. The topic is is true or false. So I found three data sets for this project. The first is Snopes, and the Snopes is a data set that all kinds of rumors reported on the internet, which are investigated manually by human editors and analyzed and labeled with credibility. And the second is PolityFact. The PolityFact is a fact-checking data set. Websites that edit and provide credibility ratings of women's statements. And the third is News Truth. The News Truth is a community's website, and this website have a data set which are the credibilities of news articles. So for these three data sets, all of these data sets have enough comments, and every comments have true and or false labels. And these comments have enough evidence, and some evidence have the evidence source. So for these three data sets, I do two parts to do the data inversions. And the first is analysis of evidence for each label in the data set used. And the second is on the basis of processing the data set, similar features were extracted for all statements and related evidence documents. That means for traditional systems, they may only predict the comments and tell people the label is true or false. But in my data set, I will predict the comments and predict the evidence and tell people the label is true or false. So for the data preparations, the first is feature selections, and the second is data cleaning, and the third is data transforms and feature engineering. And for the data preparations, first is because every data set have useful information, but it also have some information that are not necessary. So I select the useful informations, and these informations are comments, evidence, and labels. And firstly, I select this comments, evidence, and then I will do the data cleaning.
Sorry, Jiacheng, your time is up. If you can please wrap up quickly.
Okay. So the data preparations is cleaning. I use stop words and remove the words that are not nonsense to the sentence like is. So for next is I use BERT models to predict the trained word vectors models, because I need to change the data sets, change the comments and evidence to the language that computers can use it. So I change these comments to the vectors. Okay, thank you.
Okay, cool. So did you say that you're using those three data sets, or you're adding some sort of context yourself, if I understand correctly?
These three data sets I found on the internet.
Mm-hmm. So you are using them, or you're adding something extra?
No. I just use these three data sets, and I don't know what you mean.
Okay. Can you see that previous? What is the next table? Data visualization.
Yeah.
Okay. So this is the number of comments
yeah.
source. what do you mean by so the 3 data sets? So you have comments, comment source, evidence source.
Yes, I combine the comments and evidence to build predict systems.
So these numbers are the number of words or number of comments? What is it?
Number of the comments, not words.
Okay, and they could have different lengths.
Yeah.
Did you have like any distribution of those lengths? How they are distributed? Are they very long?
No.
Okay, that's cool. Thank you. We need to move to the next speaker. Jitendra, are you here?
Yeah, can you hear me?
Yes, I can. Go ahead when you're ready.
All right, I'll share the screen. Can you see it?
Yeah, all good. Yeah, all good.
Yep. Hello, my name is Jiten Singh Malik, and today I'm going to present my topic on hate speech protection, data and project goals on it. So I'm just going to give a little brief about what the project is all about. So I'm doing a text analysis in this using different kind of embeddings, which is classical and modern. I'll discuss more which are classical and modern later on. And these are the models which I'm using. So I'm dividing my project in 2 classes, and where I'm going to use classical modern embeddings. This is. So I'm going to use a balanced data set on it. So in order to remove any biases and everything, I'm going to use a balanced data set. And later on, I'm going to comparison the F1 score over it. So, as I said, I need a balanced data set because I'm doing so many embeddings. So I have tried to use a data set where number of classes are equal. So I've taken a data set from Kaggle. It contains of 6,000 rows around. And in order for that, I have applied the label encoder on it. And as we see now, first class it's having 49%, second class also having 50%. So because I'm working with the BERT model, so I don't really have to do much transformation over here, and I'm using NLP. So I don't need to use any much variable difference over here, but I still try to use it. And over here, data cleaning. So as it is a text, so pretty much which I can do is just convert the text into lower characters, remove the HTTP punctuation and all those things. So I have tried to do it. I've used this function to remove it. So I combine everything and converted text into lower, remove the stop words as well. So that's what came to conclusion what I can do with it, with the text. And these are the embedding which I'm using in it. I try to convert it to FIDF, and this is just the embedding technique which I'm using. And I've tried to use the globe embeddings because the pretty much which I can do with the text data was to put in the low character and remove some of the stop words. And in order to do feature engineering, what I had in my text was I was having 2 columns, one with a title name and text which was explaining the text which contains of it. So I'm going to do an experiment where I'm going to first combine these 2 columns and give a new column. And I'll see if it's giving me some good result. If it's not giving me a good result, I'm just going to go with the text column. So that's what pretty much I could do with the data over here.
Well, thank you. So just to make sure I understand correctly, you have some text and then the label is whether those are real news or fake news kind of thing?
Yeah, it's a fake. Mostly what matters in my models are that because it depends upon comparing the embeddings. So I just try to take a data set which is balanced, and I'm just doing a text analysis. So any data could be used, either the spam detection, or I could have used the news data set, any data set, because more importance I'm giving to the models. So data set is kind of less importance here. It's just I've tried to use a balanced data set over here.
So how do you want to compare these 2 embeddings and say which one is better and worse? What is it?
It's gonna be first I'm gonna give the confusion metrics, and so how mainly I'm focusing on F1 score, which I'm gonna get it weighted average score. So if F1 score is more for some embedding, I'm gonna say that this embedding is giving me better results. I'm gonna see the precision recall and F1 score from there. So the more the F1 score, the more I'm gonna give the preference to it that this embedding is better than the other.
Okay, so it's just in terms of performance, not any semantics or.
No, I'm just trying to obtain. I'm doing text analysis. So if I do the comparison in this, it's gonna be another big point. So main thing, if I do a comparison, it means that I'm already doing text analysis as well. And if I was just doing text analysis using one embedding, it would have been just text analysis. But now I'm using more embedding, so I can get a much further and say, okay, this embedding is better than this. So it's kind of 2 points over here. Text analysis and a comparison could also be done from here.
Yeah, but just the last comment, that could also depend on your task that you're doing.
Yeah.
So you cannot draw a conclusion saying that this embedding is going to be better in every task.
Yeah,
some of them might be. Yeah.
I'm going to be specific that on this data set, and it's a balanced data set on this, it's giving me a better result of it. So it's doing text analysis as well as a little comparison on just specific to one data set.
Excellent. Thank you. We need to move to the next speaker. Jiazin, are you ready?
Yeah, I'm here.
Yes, go ahead and share your screen, please.
Yes. Can you see the sharing?
Yep, that's all good.
Okay. Hello, everyone. This is Jiaxin. My topic is household waste recognition based on machine learning. And I will introduce the data source, data filtering, data labeling, and how to use the data set. The first part is about data source. I created 1,500 images of household waste as a data set. It was sourced in 2 parts. In the first part, I use a data set collected by others from the internet. As shown in the figure 1, this data set includes household rubbish in different places. But the disadvantages is that some of the images are not of high quality. The second part can be seen in the figure 2, which is a picture of household waste taken by myself as part of the data set. In comparison, the picture taken by myself are much clearer and the quality is better. Let's move to the next part. Because there is some bad quality data in the network dataset, I did data filtering. I defined 4 types as low quality data that needed to be removed. This includes images that are not clear, images where the type of rubbish cannot not be distinguished, duplicate images, and rubbish obscure images. In the 2 figure, the rubbish is more hidden and I can't easily distinguish the types. About the filtering method, I didn't find a particularly good way to filter the images, so I use a manual filtering. When I label the filtered data set, I choose to use label IMG for the labeling. The labeling process is shown in the figure 3. I use the smallest box possible, circling the object to allow for more accurate model training. When saving, I use the format YOLO as I planned the model to use a YOLO model. Before labeling, I set a total of 59 categories of Jack to be labeled. The category names are shown in figure 4. And then finally, on the use of the dataset, I have learned to use the train file in the YOLO without source code to train the model. This code is the commands and parameters for training the model. This is all content. Thanks for listening.
Good, thank you. So it was pretty clear. I don't have any questions. We can move to the next speaker.
Okay.
And Zijian, are you ready?
Yes, I am. Can you hear me?
Yes.
Okay. I'm gonna share my screen. Sorry. Can you see it?
Yes, it's all good. Go ahead.
All right. Oh, sorry. My screen just. Okay. Can you still see?
Yes, I can.
Okay. Yeah. Okay. Hi everyone. My name is Jian Jia. I'm going to present on the data and goals for my project COVID-19 stock price influence prediction using LSTM. I'll first introduce my goal and some of the Python packages I use in this dataset processing stage. My goal is using historical stock price data provided by Yahoo Finance to predict 30 days into the future how will different types of company stock adjusted close price and volume react under COVID-19 influence factors. For presentation, I'm just gonna use Facebook's stock history to show the process of handling the data. The time interval I selected is from June 1st, 2019 to August 30th, 2021, which indicate the whole COVID-infected time period plus 6 months before COVID. As it shows in the top left, the initial data I got from Yahoo Finance contain multiple tuples, but I'm really interested in the adjusted close price and volume because with those two values together, it could reflect the status of the company, and the prediction of those two values will be interested to analysis on. But as the plot shows, plotting the data set now won't make any sense because I need to extract the value I need and also rescale it for LSTM to use. In the cleaning stage, luckily Yahoo Finance data is very clean in the sense of formatting. All I need to do is to put adjusted close and volume into two arrays. And this time the plot for adjusted close is something I could use after rescaling. At this point, as the plot shows, right now the scale is between 150 to 350. That is too large for LSTM. So what I did is I used a min-max scaler provided by skitlearn to scale all the data between 0 and 1. After rescaling, the plot shows the data set has indeed been changed. Next thing is to prepare the data set I need for the training process of LSTM. To make the data set ready for training, I separate the data set into two sets, a training set which contains 70% of the data and a test set that contains 30%. The amount of training and testing data can be any amount, but to ensure efficient training process and better training quality, it is necessary to keep this ratio around 7 and 3. After I've done that, I also need to separate the training and testing set each into two categories, X-train, Y-train, and X-test and Y-test. X-train or X-test contain the number of days I want to use to make the prediction, and Y-train, Y-test contains the next day's predicted value. For example, in the code block on the bottom left, I use 50 days of data to predict the 51st day's value. In this case, one row in my X-train will contain those 50 days of data, and one value in the Y-train will represent the 51st day's prediction. I use create dataset method to organize my training dataset and testing dataset. The output is 346 by 50 matrix for the X-train and 346 by 1 matrix for Y-train. For X-test and Y-test is similar. Up until this point, the data set for the stock, for this company stock is almost ready to use as input to train LSTM. Next few operation will require me to build the model and test.
Yep. Sorry to interrupt you.
So those are the next few things I want to do. Just finalize the COVID-19 factors and build the model. That's it. Thanks.
Great, thank you. All good. We had Xingzhou, who had problems with the internet. Xinhao, are you here? Do you want to just try presenting again?
Oh, should I? Okay.
Yeah, you can stop. Thank you. Yeah.
All right.
Our next speaker. Xinhao, can you hear me? Okay, if you still have problems, you can try at the end of the session if there is time. If not, you can contact over email to see what you can do. So I'll need to hand over to Christian, who will be taking care of this session. And yes, the next speaker, with Christian, you can basically take over.
Thank you.
Thank you, Christian, and see you guys.
See you. I think next speaker is Twisha Bunker. Twisha. Okay, seems that she's listening them.
Yeah, I'm here.
You can start.
Yeah. I share my screen. Can you see my screen?
Yes, I can.
All right. So, hello, my name is Denishin. Today I'm going to introduce the data and the goal of my project called the Workout Assistant. First of all, the goal of the project is to identify whether a workout movement is standard by uploading pictures. This project will complete the recognition of a basic and classic workout movement, single leg deadlift. we can see that the workout movement is a dynamic process. But in order to determine whether the movement is standard, we can decompose the movement into several key and representative static poses. Here we can decompose the single legged deadlift into two poses. One is in the standing state, which is the beginning and the end movement state. The other is bent over. When our system receives the two photos, we can determine the class of them respectively only when the pictures are recognized as the corresponding correct class of pose. We can see that this is a standard single leg deadlift. So there is no ready made data set. I have collected 1,500 photos of workout poses, including photos on the internet and screenshots of training videos. These photos are divided into three classes: pose 1 and pose 2, and some wrong poses marked as wrong pose. But the dataset is small, so term for the course validation is adopted for the model. It will divide the dataset into 10 pieces of the same size, randomly select one piece each time as the test set, and the remaining 9 pieces as the training set. After several rounds, the loss function is selected to evaluate the optimal model and the parameters. So with the dataset, how can we convert them into data that can achieve the project goal? First, the pose pictures decomposed by the real-world movement are input to the system. Then we extract useful features from the input. In this system, the key information is human posture. Through the PoseNet model, we will recognize the input photos and get the position and the confidence scores of 17 key points of the human body. At the same time, we can mark these points to get intuitive and abstract human pose. Next, data transform. The first step of this project is scaling, which maps the data to the range of 0 to 1 for processing, which is more convenient, fast, and comparable. The second step is L2 normalization, which is to prevent the model from being too complex to meet the training set, resulting in overfitting, so as to improve the generalization ability of the model. After these steps of data processing, from the input pictures, we will get a series of corresponding vectors reflecting human posture that are easier to process in the range of 0 to 1, which makes it more convenient and accurate for us to use the data in the further classifier training. Thank you. That's all.
Thank you. I have some questions. Can you get back to the second slide, I think?
This one?
No, 2 more. Sorry.
2 more. Oh, sorry.
Yeah, sorry, my fault. So my question is, you are doing the annotation of the human pose, isn't it?
Yeah.
Okay. Okay. Just a recommendation. There is one dataset that probably you can take a look, which is JHMDB, which is Joint Human Movie Database, and they have joints of each of the human motion, and there are some activities that are related to what you are showing here.
Yeah, but and the problem is I want to recognize the workout movement, like in my project is the single leg deadlift. Is the movement is standard or not? So the hard part of the dataset is I can't find any dataset about this movement. So I'm just collect some picture from the bodybuilder and some screenshots from their training video, which is the standard pose.
Thank you. Thank you. Make this clear for me. I think we can wait 2 minutes. I had been told that there should be a rest here. So after that, I think I'm going to keep with Twisha Bunker is here, isn't it?
Yes, I am.
Yeah, great. We can start to shape you want?
Yep, sounds good. I'll just share my screen. Can you see?
Yes, I can.
Okay. All right, so hi everyone. Just a quick recap. My project is looking at using sentiment analysis in text for identifying potential signs of depression and anxiety, which forms the overall goal of the project. So the data that I'm working with is from data.world, consisting of 40,000 tweets with different participant IDs and labels of the emotions present in the tweets itself. The labels are provided here, but the main ones that I'm investigating are sadness, worry, anger, hatred, and emptiness, as these are the main ones that relate best to my topic. So the data distribution is displayed here, and I see that the most of the distribution is concentrated around neutral and the worry emotions. The neutral tweets will form heavily the basis for my control group, for example. Additionally, as we can see from the screenshots, I believe that some of the labels have been misidentified due to unique perception. As such, part of my data cleaning process would be making sure that most of the labels resonate properly with their supplied labels, following one-hot encoding them for numerical representation. And the main thing is that most of these do actually resonate with the message that is being sent out, but the problem is that these tweets are actually sent out to the general public and they're paid to actually give their opinion on what they think the person is feeling or was feeling at the time when they tweeted it. So that opinion does vary, but usually it's fine. And as for the technical aspects, the first thing will be removing any punctuation and stop words that hinder the ability to train the model. However, in the case where there are, for example, multiple exclamation marks, I'm proposing to actually create a feature for this, as this often indicates frustration or excitement. And I know this from personal experience, like if I'm texting somebody or if I'm frustrated or angry, I might use multiple exclamation marks to actually display my frustration, and that brings in that novelty side of things, and also using emojis as well. I think that that's something that hasn't been really looked into too much in a textual context, so that's something that I want to examine as well. I'll also be vectorizing the words using the TF-IDF vectorizer and count vectorizer to assess the frequency of each word, and preparing a vocabulary for the data set. Additionally, what I found was that some users had multiple tweets, and it would be interesting to identify if there are any key phrases or terms that they use repetitively, and consider this with a binary label to indicate the possible presence of a verbal dissatisfaction as part of the feature engineering process. As for visualization purposes and to assess how well these features are matching up with the emotions displayed, I will be creating cross-correlation matrices as shown here, to correlate how well this speech is reflecting the emotion that the user has displayed. And lastly, depending on which features stand out using the correlation matrices, I will be employing a dimensionality reduction. But this will most likely be done manually because I don't have that many features. But hopefully that works well with identifying the highest correlations with the labels provided. Thank you.
Thank you. I don't have any question for you. Thank you so much. I think next one is Chong Chin.
Yeah, I'm here. Give me a second.
Sure.
Could you show me my? Could you see my share screen?
Yes, I can.
Okay. So I'm going to start. Good day, everyone. Chong Chen. My topic of this one is to make the human activity, human motivation get categorized in the weightlifting training. So, for example, honestly, we have to collect the most important data is to collect the weight training data sets. So therefore, I got two different categories. One is open source data set, and another one is my self collected data. My project goal is zero human motivation defining. For example, once you're doing a deadlifting or to handle some weights in your physical training, you can define what is it and to define the quantity is it. So the data set I use currently is I collect the weightlifting exercise data sets, and there's another one called UCF. UCF is multiple videos to collect human activity, including sports, including playing instruments or making makeup or something like that. But the most important thing is we collect the motivation or the location of each junction of the human friends. For example, the row belts or the pitch belts. The rate block is the entire movement of the one single training, for example, deadlifting. So you can see that there's maybe 10 friends, so we can understand the serial movement is it. So another one is what I mentioned before, UCF 101. You can see there's a lot of videos, but it didn't provide the specific location of the human skeleton or human junction in the entire movement. So including the data what I collect from YouTube or some international powerlifting associations. For example, this one. This one provides a standard movement of the one deadlift. So we consider it as a standard. So once I start to generate the movement of skeleton, as we can see here, we picture the friend and we collect all the skeleton movements. Therefore, we can use these data sets to start training our friend. So this the data set I'm looking for, and I'm currently to clean to collect and clean the data I collect. So in the future, I assume there will be a lot of data will point out the human skeleton and during the movement. So this is what I currently doing. That's it.
Thank you. I have a question. Like the joints that you get in the video that you present, can you show again? Okay, that is enough. Do you get that from the annotations of the video, or are you getting that from
my program? This is the actual running from my program. So as you can see, the for example, this one 7 means the shoulder, and this is the location of the shoulder.
Yeah. But did you make these annotations, or you have take it from the data set?
Oh, this the raw data, the videos I collected from the internet and I created it. So the data set here is created another different data set.
Right. So the joins has been annotated by yourself.
Yes, correct.
Okay, fair enough. Thank you. I think I don't have any other question.
Thank you, sir.
Rush, Kiran, Kaur.
Yes, hello. I'll share my screen.
Thank you, but can you wait me a little bit just to take notes about the previous presentation?
Yeah, sure, that's fine.
You can share the screen right in the middle if you want. Yeah, we can continue.
Okay.
Wherever you want.
Sorry?
Whenever you want.
Yeah, okay, sure. Hi, so today I'm going to present on classifying poisonous mushrooms using machine learning. Is it going next on your screen? Oh, sorry, okay. So the goals of my project is to predict the edibility of mushrooms using machine learning and also the data set. To identify the features that are most indicative of poisonous mushrooms and also to classify the poisonous mushrooms against the edible mushrooms. And the tools that I use to prepare the data, to process the data, is Jupyter Notebook, and some of the libraries are NumPy, Pandas, Matplotlib, Seaborn, and sklearn. And this is just to present my data. This data set was obtained from Kaggle. And as you can see, the data, the content of the data is in a text label. And this is a problem because it's very hard to work with text, especially since there are so many different categories. This is just to show the labels of my data. There's 23 columns and 8,124 rows. And when cleaning it, it shows here that there are no null data. So therefore, I didn't need to drop any values. And the number of rows remain the same. Just a brief description of the data. This shows the unique values of the 23 different columns. So like for the first one, it's showing poisonous and edible. So the values are 2 different unique values, and similarly for the other categories. And it also shows the count for each category, which is edible, which is 4,208, and poisonous 3,916. And then this, I plotted the data just to show a visualization of poisonous against edible. And I also checked the ratio of poisonous mushrooms against the edible mushroom, and it comes down to 0.93. So because earlier I mentioned that the data was in a text label, I converted the data into numerical using label encoder from sklearn preprocessing. And the unique value in a given feature was converted to its own numeric label using the encoder. And then I created a dictionary to store the numeric labels. And this mapping shows, for example, the 0 here is for edible and 1 is for poisonous, which you can see here. And similarly for the other categories, they also have provided the dictionary for those labels. And then moving on, the data, I decided to also scale the data, use the standard scaler from sklearn preprocessing. And I did this in order to ensure that the labels have univariance. And I used to normalize the range of independent variables of the features of the data. And this is how it ended up looking. And the next step is to implement a machine learning model on the data, to train the data set, and then to analyze the results. Thank you.
Question, do you have pictures of each of the type of mushrooms, or is just
no, it's all just text.
Yeah.
It's all just like this. This is extracted from the Excel sheet that I found, the data set.
Right. Yeah, perfect. Yeah. Thank you.
Thank you.
So we can go with Qingjing Zhao.
Hello, can you see my screen now?
Yes, can you give me just 1 second? Okay, we can proceed whenever you want.
Okay. Hello everyone. Today my topic is about prediction of users' suicidal tendency according to social media posts based on machine learning. This project is a natural language processing project. Specifically, I intend to predict users' suicidal tendency through text learning. Today I'm going to show the data set I use. This is the dataset I found online. There is text and a class in this CSV file. The data is clear and it is useful for my project. I found the dataset in this website. The author claimed that the class labels were not labeled manually, and the posts collected from this website related to suicide watch are labeled suicide. Okay, I will use plots to show you the information about this dataset. The dataset contains about 200,000 samples, which is very huge, and we can see that the number of suicide labels is as same as the non-suicide labels. I selected 80% of the samples as the training set, and the other 20% as the test set. The number of two texts in the training set is also the same. Okay, this bar chart shows the number of words in this CSV file. The blue one represents the original data. The pink one shows the number of trained data words. I used the text blob library to proofread the spelling of text words. And I dropped a unnamed column, and I removed the stop word and converted uppercase letters to lowercase. In addition, I removed the top 10 words with the highest frequency. That is feature selection. Finally, the cleaned training set data is obtained. Next is the data pre-processing. I choose to use tokenizers to generate a dictionary for counting word frequency and then convert the words in each document into vector form, and then add the same length through padding to realize data processing. I also assign the tag and encoding between 0 and 1 because I only have the two labels, the suicide and the non-suicide. I use the globe embedding method to reduce the dimension of the vector. I put the vector into the matrix with a maximum length of 300. This is the result I got. Thank you.
Can I look the two things? One is the data preparation slide.
Okay.
One before, sorry. Sorry, the cleaning data.
The cleaned data.
So, even though that you make the removing common words, do you know what are the common words that you have removed?
I removed the most 10 frequency word because it doesn't make any sense in this to predict the suicidal tendency. So
Right.
I removed that.
Right, like I just wondering what is the difference between the stop words and common words. So I know that the stop words could be also extracted using the frequency of each of the words, but yeah, I guess it's something to take a look. And then if you can go to the previous last slide.
This one.
No, the last slide, that one, the global. So you mean that you have this vector is a vector of words, and then you pass it to a matrix of the global embeddings, right?
Oh yeah.
So my question is, the word embeddings is 300 embedding space for each of the words. So when you say that you limited the amount of size, what do you mean with 300?
Oh yeah, because I use the global embedding dictionary, and the set of this dictionary is 300. It is the maximum vector length.
Yeah,
So
right.
I set that. I set 300.
Yeah, like I just want to clarify that the global embedding is per word, not the dictionary, because the dictionary is almost all the words that you have in the Wikipedia.
Oh, okay, thank you.
Yeah, yeah, but that's all. Thank you.
Okay, thank you.
I guess next one is Guli Sao.
Yeah, Oli is here. And just 1 second, I will share my screen.
No worries, I need to take some notes, so you can.
Okay. So I'll start after you finish with the notes.
Yeah, thank you. Sorry for
that. That's all right.
I think you're gonna start. Yep, you're gonna start.
Yep. Okay, good afternoon, everyone. This is Wu Lizhuo, and my project goal is to predict coffee quality from non-measured features of coffee beans, such as the origin of the country and the altitude. And my data set gives 43 attributes, among which the bean metadata and the farm metadata are very useful for reaching my research goal. So let's first take a look at data distribution. In terms of total cut points, which are the label of the problem, it is mainly between 60 and 100, and the majority of the samples are Arabica. I drew some plots to illustrate the relationships of total cut points with the variables. We see that the Arabica base tend to give slightly higher scores than Robusta, and there is more variation in scores with country of origin region and bean variety. There is no clear trace in the relationships of total cut points with numeric variables. And we also found that there are some missing values to be dealt with. So with the basic information of the data set, we can get started with the pre-processing. Firstly, I removed the most obvious outliers and fixed those imperfect values. And some unwanted attributes can be dropped from the very beginning. So most processing for MISI data are quite natural. For example, for the MISI altitude, I imputed the mean altitude of the region. For those MISI values that are hard to make deductions about, I filled with unknown, though this isn't usually considered as a good method, so I deal with them later in the feature selection stage. So, before proceeding a feature selection, I first manually distinguished the best fields to use among some correlative variables and drop the others. Now we have 12 attributes left. I use techniques including univariate analysis with chi-square, mutual information, and random forest to help select features. To do this, I need to normalize the data, and categorical features should be transformed into numeric ones by using one-hot encoding. But if I use tree-based models, then we may not need one-hot encoding. So these two bar charts show the correlation values and mutual information of numeric features, and this is the importance of all 700 features given by 3 different techniques. So taking all the results into account, I decided to use these 30 best features, including all the numeric features and the important features transformed from categorical features. When training with machine learning model, I will use PCA as the dimension reduction technique. So I think that's all for today. Thank you.
Sorry, I was muted. Just thank you. I just have one question. Where do you get this data?
This data is from an authority here. Yeah, it's from an authority named the CQI Coffee Quality Institution. And the data was originally uploaded in this website. And I can also find some other sources like in GitHub repository and also Kaggle.
Great. Thank you.
So, any other question?
No other question. Thank you.
Okay, thank you.
I think next one is Wen Hao.
Yes.
You guys start by sharing the screen. I need to take some notes. Yeah, you can start.
Okay. Good afternoon, everyone. Today I'm going to introduce the dataset I will use in the project brain tumor radiogenomic classification. The raw data are collected from the following 3 sources. All of the datasets are collected from real patients' MRI scans. The data contains 400,000 DCM files. A DCM file is an image file saved in the Digital Imaging and Communications in Medicine image format. All of them are structured as shown on the right hand. All the DCM files are grouped by cases. Each dependent case has a dedicated folder identified by a 5-digit number. Within each of these case folders, there are 4 subfolders, each of them corresponding to each of the structure multiparametric MRI scans. The exact MRI scans include are FLAIR, T1W, T1GD, and T2. And here I show the video of the 4 types. And you might want to know what the differences among 4 types of MRI scans are. Here I used the Python Docker image to generate 4 types of MRI scans using 0001 8 as an example to show the difference among 4 types of MRI scans. In total, there are 585 cases. The MGMT promoter methylation status among all cases are balanced. MGMT promoter methylation is a specific genetic sequence. It is a favorable prognostic factor and a strong predictor of responsiveness to chemotherapy. However, the characterization of this genetic sequence has not been identified. All the cases contain tumor. Some tumors have MGMT mutation, and the 70% of the dataset will be randomly arranged as training set. At data cleaning, the case labeled 00109, 00123, and 00709 might cause unexpected issues, so they are temporarily excluded from the dataset. The future selection according to Han et al., the multifocal tumor cross midline tumor location enhancement, cyst, necrosis, edema are considered as features in this project. There is not really common agreement of the scientific community on which modality is best, and that past study indicates that different tumor features are revealed best with some combo. In different MRI image methods, fat, water, etc. are painted by different colors. The combination of 4 types of MRI images might help to identify the characterization of MGMT promoter methylation. And here are my references, and thanks for listening.
Yeah, thank you. Can you explain why those cases labeled are possibly misleading? I mean, like what you say that.
Because you mean these 3 cases? Because I checked the whole data set. These 3 cases missed some design files, so you cannot create a very complete matrix to generate the matrix for the brain. So I just excluded from the dataset.
Right. Thank you.
Thank you.
Next one, Julian Cabezas.
Yes, here I am. Can you hear me?
Yes, I can.
Okay, we'll share screen. Okay. Can you see the presentation?
Yeah, I can see. Just give me a second, please.
Of course.
Okay, we can go.
Okay, hello everyone.
Wait. I am seeing your folder downloads.
Oh, sorry.
No
what
worries.
happened? Here I am. Okay, now you see my presentation, huh?
Yes.
Yes. Okay, hello everyone. My name is Julian Cabezas, and I will be presenting my data and project goals for my automatic gun violence index for movies. So, a little bit of an overview. My project goal is to train a model to detect guns in movies, to create an index that can tell us how violent a movie can be by seeing the number of frames with a detected gun versus the total number of frames. To train this model, I'm going to use the Open Images dataset as training and validation. And for testing, I will use the movie trailers that are available on YouTube, like real data. So my first data source is the Open Images dataset. That's a massive dataset of labeled data, and I'm going to use the weapon tag that contains, as you can see on the right image, object detection labels for different kinds of weapons. And I will use them to train a faster RCNN object detection model. First of all, I had to clean the data because it contains different kinds of weapons, such as swords and toys. And I used the firearm definition under US law as main criteria, along with many others. So I went from almost 2,000 images to 1,200 images containing guns, as you can see on the image. And I also added the same amount of images not containing weapons as negative samples. I converted the dataset to COCO format, and I split it into training, validation, and testing that I will also be using for the model. And as you can see on the graph, most of the images contain either 0, 1, or 2 guns, and they are most of them small or medium, like pistols, for example. I'm going to use data transformation in the form of data augmentation methods in the training pipeline, such as random crop, random brightness, contrast, and saturation, and random horizontal flip. Here you can see an example. The top is the original image, and the bottom is the transformed image. And I'm going to use the YouTube trailers to test the model. So I went for PG-13 movie trailers because that's my focus on the project, movies that kids or teenagers can see. I'm going to use this data as real data, as the movies data. So I went for the top PG-13 movies ranked by lifetime gross in the USA. I recorded the YouTube trailer, and I did a preliminary analysis of gun presence. So I got a database of 38 movies, 26 containing guns, like, for example, Avatar, Star Wars, Avengers, movies we all know. And I'm going to make a manual calculation of the gun violence index by visualizing the YouTube trailer using very low speeds to get this index manually classified by getting the time with a detected gun versus the total time of the trailer. And I'm going to compare this manually calculated index with the index that I will get with my model. So that will be it. Thank you very much.
I have a few questions.
Mm-hmm.
So, do you have any average duration of the videos?
Of the YouTube trailers, is mostly between 2 and 3 minutes. Those are because I don't have the processing power to go for whole movies.
Right, makes sense. And are you planning to do frame analysis, or are you going to subsampling the video, the 2 to 3 trailer video?
I'm going to probably use subsampling because of processing power, probably around 4 frames per second or something like that. I have to still see that.
Okay, so it's something to consider as a pre-processing thing, how many frames you're going to extract per second.
That's true.
But apart of that, thank you. It's really interesting.
Thank you very much.
Okay, so next one is Tianlei Chi.
Yes, I'm here.
You can start wherever you want.
I think that's good.
Yes.
It might show up.
Yes, you can start.
Good afternoon, everyone. My name is Tianlei Qi. My project is a software vulnerability detection method based on the random forest algorithm. Today, I'm going to introduce the project data source and the data preprocessing strategy. The project will use the two open source software, FFmpeg and LiveTIFF, as sample datasets. FFmpeg is a computer program that can be used to record and convert the digital audio and videos. LiveTIFF is a project used for .tiff image format to read and write. The vulnerability data of those two softwares are collected from the CVE, Common Vulnerability and Exposures. CVE provides a public reference for publicly known cybersecurity vulnerabilities and recognized by the industry. The data version is from early 2005 until October of 2017. I use public and open source datasets because the open source project can be downloaded by anyone in the future. Others can replicate or verify the method in the future. And there are 5,565 non-vulnerable functions and 191 vulnerable functions in FFmpeg datasets, and it will use for training the model. There are 731 non-vulnerable functions and 94 vulnerable functions in LiveTIFF dataset, and it will use for model training. As for identifying the labels, the non-vulnerable functions are named as the original names. However, the vulnerable functions are indicated by the keyword CVE and ID, which can show on the right side in the screenshot. Since the data is downloaded from the open source project and CVE, all data will be used for training and already labeled. So the data cleaning part will be skipped in this project. And the AST will be used as the key features of the code. AST stands for Abstract Syntax Tree, which extracts the structure of the code in a tree form. It shows the relationship of the components and also the control flow at the function level. The external tool, open source tool code sensor will be used for extracting the AST from the source code. As for data transform, the AST generated by the code sensor is like the screenshot on the left. Next step is to serialize the AST need to be transformed into a long sentence with the semantic meaning. The semantic meaning is formed by the elements of the vectors and their sequence. So in the screenshot shown on the right, each function will become a long row, and each column in that row represents its AST node. The sequence in that row indicates the position in the AST. Therefore, the two-dimensional AST could be converted into one-dimensional textual vectors. For feature engineering, fitting a random forest model, the textual vector should be transformed into a numerical vectors. I create a Python function to map the node name into numbers, then save the numerical vectors for further model training. As for dimension reduction, since the different functions have different lengths, it will result in the dimension of each data is different. So I added a padding function to limit the max length of the 650 to keep the essential features. The value beyond that length will be removed for reducing the extreme value in datasets. Only keep the essential features will increase the generalization of the model. Also, reduce the dimension will greatly reduce the execution time. For the samples less than 650 length, the padding function will fill 0 to it. So that's all for the data preparation of my project. Thanks for listening.
I have one question, but it's because I couldn't follow. Can you please explain me why we don't need data cleaning in the code?
Oh, so because the FFmpeg I'm using is already the public version. So I examine it to check whether it has some useless function or something blank. But actually, the public version is already very complete. So it doesn't have any useless functions. And I use for training, so I use all of them for training instead of deleting something or pick out something. Also, the CVE is already the verified and checked vulnerabilities, and then it will be uploaded to the CVE database. So I think it should be already processed the data. So I didn't doing the data cleans.
Okay. Right. Fair enough. I think it's okay for me. I don't have any other question.
Okay, thanks.
Give me 1 second, please. Just need one more. So next one is Sridhya Atula. I'm sorry if I couldn't spell well the name. Sridhya? Hello, can you hear me? Hello, can you hear me? I guess the next one is Jun Lao Liu.
Yes, I'm here.
Yeah, you can go if you want.
Okay. Can you see my screen?
Yes, I can see your screen.
Okay, hello everyone, I'm Yulong Yun. Now I will start my presentation on the data and the project goals. My subject is fitness posture guidance, and the final goal is to complete an Android-based fitness posture guidance app. And the specific function is to analyze people's posture during fitness through the phone camera and take the one action photos or count the correct action. And here I will use the squat action as an example. Data size introduction. There are very few fitness data sets, also because there are also many types of fitness posture. And so it is difficult to confirm the data set for one posture. The good news is that there are many fitness teaching videos on the internet. So I collected these videos, and this video basically from a side angle, and the camera head is basically in the same level. In order to ensure the accuracy of this data, this video have more than 1,500 likes and views time. For processing. The first, the human body in the video is enlarged and the resolution is reduced. It's saved by GIF. The reason of this is to reduce the space and better to extract the key frames. And the better training result is to use the mobile phone camera. Positive train set and negative train set. Basically, every teaching video will mention some one posture and make one demonstration. So this one posture also be posted and saved and marked as error for the future training. Data transform. In order to simplify the judgment of the posture, the gift in the data set will be first mark the key point of the skeleton and save it. The key point will be stored and in the data list in the form of the coordinated. Feature selection. Since the arm in this whole posture is not limited, so the key point will only refer to the remain 10 point. And because people have different speed and amplitudes during the exercise, and the number of the repetition of action are also different. So during the video processing, only the key frame will be recorded as the future point coordinated. And in this way, we can obtain the keyframe and process it data. The action in each gift will repeat at least twice. So after the processing, we will obtain more than 800 frame of the key point data. Feature engineering. The accuracy of the squared action depends on the body's center of the gravity and the spot of the legs. In the correct squared process, the line between the shoulder and hips are nearly parallel to the line between the knees and feet. So therefore, through the key point coordinate, the slope of these lines will also be entered and as a future value to help judgment. To increase the accuracy in the accurate judgment of this action, the relevant posture, the relevant position of the point and the angle of the collection will be used as a reference standard. That's all. Thank you.
Thank you. Just one question: how do you select the keyframes?
Yes, the keyframe is selected by it is depend on the key point position have obtain movement. I mean, so when you start to make a squat and your leg and your body will first have the position changing, and that will be the selected implementation, selected in.
Thank you. From where are you getting these videos? YouTube, isn't it?
Those videos major come from the YouTube and Bilibili, which is a Chinese video website.
Yes, I see that one, but I didn't know what is Bilibili. Thank you so much. I think next one is Suri Divya.
Yeah, thank you, Kristen. Actually,
no worries. I mean, like, sorry for my pronunciation. Probably you didn't hear me.
No, I was on, but I'm practicing and I forgot the presentation.
It's okay.
Yeah.
Can you please share the screen? In the meanwhile, I'm taking some notes.
Just give me a second. Yeah, you can see it, right?
Not yet, but give me a second. I am just taking notes.
Oh yeah, sure, of course, yeah.
Okay, you're gonna start.
Yeah. Hi, I'm Sridivya Akula. I'm here to present project goals and data information related to our project, which is predicting negativity of reviews based on the score. And these are the contents: project goals, application summary, data collection, data analysis, data pre-processing, and plan and the references. The main project goal is to predict negativity of reviews based on the score, and this can be useful in the computer-based platform. Our main motivation of this project is considering self-influencers. So this is how our application summary is. Like for each reviews, we will give a score, and if our self-influencer want to maintain their negativity of this platform, for example, like 2.5. So all the above 2.5 scores will be removed. So this is able to maintain the standards of their platform. And we collected data collection from toxic comment classification project. And why we collected this data set from this project, because as our main motivation is considering self-influencer, we want reviewers from one particular self-platforms, not considering like different platforms. So this is how we can able to develop our model to reach our goal. And this is how we done data analysis. Once we collected data collections, we observe the data, like how many rows and columns will be in the trained data, and after that we observe like how most common used words from random sample of 1,000 reviews. Once we got the information, we calculate all the reviews. Then we remove the stopwatch, which is data cleaning, and we display, to understand more about data, then we display the frequent words and distribution of target variables. And these are the results of our data analysis. This is the top 5, and this is the below top 5 rows of the data set. And these are the most frequent words used in the data set. And these are the results of distribution of target variables. We actually have 6 target variables in the data set. So once we got the data set, then we done, data analysis, then we did data pre-processing, which is combined all the target variables into one variable, and we generated new features. And before doing text transformation for the model building, we characterize as a 1, 2, 3, 4 instead of 1, 2, 3, 4, 5, and 6. And then we remove the numerical data and symbols, which is data triggering. Then using counting vectors, we transfer text data into like numerical data for the model. And the main plan of our project is like, first we collect the data collections and the text classification, and we generate a score. And how we generate the score is like, the more the classified the review is, the higher chances of negative scores. So if the particular review has been classified like more, like we have 6 target variables, so if it's classified into 4, then we are going to give highest chances of negativity score. So once we able to develop this model, and they can able to maintain the standards by fixing a particular score they needed in their platform. And these are the references. Any questions?
No, really. Thank you so much. It's clear for me.
No worries. Thank you.
I think that's it. I don't know if there is anyone else that has to do the presentation. It's not Jing Hao Wang Q, is it? Jing Hao? Hello. I cannot hear you, but I can see that you unmute yourself.
Oh, sorry. Can you hear me?
Yes, I can hear you now.
My computer have some problem when I'm doing a Zoom show and the PowerPoint, my computer will break. I don't know why.
So that means that you want to try the presentation again, or you want to talk with Chief?
Can I do the presentation tomorrow or video presentation?
Can we try one more time? And if you fell down, maybe we can talk with you. What is the next?
Okay.
Option. I can see your screen.
Okay.
Give me 1 second. Just I'm going to finish with some notes, and then we can start the presentation.
Okay.
Okay. Please go ahead.
Hi, I'm Xin Hao. Today I'm going to present the data and the project goals of my topic. And the first data is the number of international students from Australia government website. And the next data set is what I made by myself from the timeline of the 21st century from the Wikipedia. And for the data preparation, what I do the data cleaning and the filter selection is I delete the data which is not which will not affect the international students come to Australia to study, and the global event, and for the future engineering, we can use before government event data to predict the future data, for example, from the financial crisis to predict the COVID-19. And the project goal for my project are predicting the future change of the number of international students when a global event happened. Like study the change before the global event before happened. What's the change between the after and the before, and to predict what will the change after a global event happen. That's my reference.
Great. So I just want to know what is the data preparation that you did. I didn't get it really well.
Because as we know, every year will have many global events happen, but there is some will affect the international student come to other country to study. So some unuseful event I deleted.
Right, so you're using the Wikipedia to get the events, and then you're marking that one, right?
Yeah.
And then how you use that event, like you say 0 doesn't happen anything, and then you put a 1 when something is happening?
Sorry, can you say again?
Yeah, so in this table that you show me, the spreadsheet that you're showing to us, is like you have an event that is happening in 2002 in probably, sorry?
This one?
Well, yes, I was looking at the table that you show us before. So you have an event that is happening in 2002 October, October. Then that is probably related to what you get in Wikipedia, but then how you use that one?
In this line, when the approach checks the number have some unknown specific change, and then it will go back to this table to check if there are any global event happen, and match them together.
Okay.
And then next time when a global event happens, it will go to predict as the event happened before. Something like this.
Thank you.
Thank you.
I think there is no one else that has to do the presentation, isn't it? I'm just going to wait 1 minute. Okay, thank you so much. Have a good day.
Recording stopped.